Hey folks, I want to go back and give you a clean version of problem 5. I felt bad after I got partway through it. I realized, man, I did a sorry job with that problem. So let's see if I can do better with it and give you a nice clean something to go by here. Sorry. There we go. No, what happened was I had it worked out. I thought I had it worked out, and then realized that what I had worked out here wasn't right. And then I made one little slip with the indices that made everything just kind of difficult. But let's go through and see if we can knock it out. So the problem here is that if we want to show that if m is a natural number that's a palindrome with an even number of digits, then m has to be divisible by 11. Okay, it's a multiple of 11. So we start by representing the number m, okay? And we say, all right, let m be, and I remember this notation where they, putting stuff in these angle brackets means that we're not multiplying the numbers together. These are the digits in a, digits in a numeral that represents the number m, right? So, and really the way I tend to think of this is, okay, d0 would be in your 10 to the 0th place, that kind of thing. And then d1, and on up, dk minus 1, dk. But if it's a palindrome, then you turn around and it goes back the other way. dk minus 1, dot, dot, dot. And then d1 and d0. Okay? So, in each of these cases, that's the format this would have. And we've guaranteed now that it has an even number of digits because we're going 0 to k twice. Right? 0 to k and then 0 to k that way. All right. So what we want to look at is, to show it's a divisible by 11, is actually the divisibility test for 11, okay? Which means we look at the ones digit and the hundreds digit, kind of the odd number digits through there, and add them, and then take the even number digits and subtract them. And that gives us then a result. And if that result is divisible by 11, then the entire number is divisible by 11. Okay. So consider now the careful thing, and this is where I got a little messed up last time, is in making sure that we do this correctly. We don't know if k is even or odd, so when we start getting up to k, we got to be a little careful, right? So, okay, so we'll start with the ones digit, we'll add it, and then we'll subtract the d1. If you'll notice what's happening here, right, the sign in front of these things, okay, is tied to the index. Okay, it's also tied to position, but also to index. All right. So if we can do index until we get up to dk, and then we're going to have to do position. So we're probably better off to do position throughout. This is in the first position, and it's positive. Okay, we want to think about putting a -1 to a power in there, but it's going to have to be not the position, -1 to the position. This would be -1 to the first position, a 1. So we're going to have to go by its position, either -1 or +1. Okay, so I'll do the +1, I guess. Dot, dot, dot. It doesn't really matter. So you do this, you get up here to minus 1. We're looking now at d sub k minus 1. And we can still kind of go by index here, but you got to remember this is in the kth position, right? So I guess if I'm going to go have it at least match the indices for the moment, I would have it k minus 1. That's fine. So kth position, k minus 1, 1 less. Okay. That ensures that that gives us the right sign in front of this. And it matches up with what we've got here too. This would be a negative 1 to the 1. Okay. But it's really position minus 1. That's what we're thinking with these negatives. And then we've got D. So I've got my negative 1 here. D to the K, which is in the K plus 1 position, right? Because K, and then you got the 0 here. So, but then subtract 1, so this is K. Alright, so at least up until that point, the indices are matching up, and that's where I messed up when I did before. But we're thinking with that negative 1, the position in the, what power 10 is that associated with, and then subtracting 1. No, I don't even want to do that. I don't want to say what power of 10 is connected with, because that's always 1 less 2. It's alright. So position. First position, negative 1 to the 0. Second position, negative 1 to the 2 minus 1, 1. Okay. And they're matching up until there. This is where it got a little funky. Now we're going to the other side here. And I've still got D sub K. Alright. That's now we're going down the other side of the palindrome, right? This is going to be, this was the K plus 1 position. This is the K plus 2 position, minus 1. So this is K plus 1. Okay. Plus negative 1 dk minus 1. And now this is to the K plus 2, right? This is K plus 1. This is K plus 1, K plus 2, K plus 3 position is, and then subtract 1, so K plus 2. In fact, you can see the progression here in the middle. We've got 4 in a row. You can see negative 1 to the K minus 1, negative 1 to the K, negative 1 to K plus 1, negative 1 to K plus 2 right there. All right, now dot, dot, dot. And this is where I got messed up last time. Let's think of what we've got here. We've got a total of 2k plus 2, because you got the 2 zeros. So this is the 2k plus 2 position, and this D1 is in the 2k plus 1 position. So 2k plus 1 minus 1, that's 2k. We got D to the 1. And then 2k plus 2 position here, minus 1. So negative 1 to the 2k plus 1, and that's the D0. Okay? And let's worry about what this is equal to. Well, okay, we've got D0. Let's look at our D0s we've got here. And then we've got plus a negative 1 to the 2k plus 1 D0. Let me kind of put those together. And then I've got a negative D1 plus a negative 1 to the 2k D1. Alright. Plus dot 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 plus. Now let's do the D sub k minus 1s. I've got negative 1 to the k minus 1. And then I've got plus negative 1 to the k plus 2. Okay. I left out my dk minus 1 and my dk minus 1. Sorry about that. plus, and this should be our last one, -1 to the k, and then here's the other one right beside it, d sub k plus -1 to the k plus 1 d to the k. All right, and also it occurred to me that I could make this look more obvious what's happening with these if I just get everything really to just either plain old minuses or just to the k, you know. So let's do this. I would factor out, actually factor out the d sub 0 here, so that leaves me with a 1. And then this -1, this is actually -1 squared, okay, which is 1 to the k power, which is 1, times another -1. So this is actually -1. Okay, very obvious thing happens there, right? Then let me get the d1 out of this one. So that leaves me with a negative. And then this is a -1 squared, right, which is 1, then raised to the k power, which is still 1. So that's plus 1. Plus, oh, I meant to pull out my, let me do that, d sub k minus 1. And so here, this -1, it's -1 to the -1 is still a -1, right? It's 1 over a -1, big deal. So this is a negative. Here's a good way to think about this. This is a negative -1 to the k, right here. And then this is -1 to the k, right, times -1 squared. Well, -1 squared is 1. So this is plus -1 to the k. All right. And then on this last one, I'll factor out the d sub k. I've got right here a -1 to the k. And again, this -1 to the k times another -1 is a minus -1 to the k. All right. So 0, right? 0, right? I don't know which one of these is which, but they've got different signs. So 0, right? And then I don't know which of these has particular signs. It depends on whether k is even or odd. But there's the same thing here and here, and they're subtracted. So this. So that gives us 0. Okay. So since 11 divides 0, then 11 divides m, or we can say that m is a multiple of 11. Boop, 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 boop. Okay, so that's cleaner. In fact, I almost got through with no marks at all, except for that one right there. A cleaner and better description of why that's true, and I apologize for my fumbling around on it on the first time, but that at least gives you a nice clean look at the proof to number 5. Okay, lecture coming soon. I just got to find the time to record it, and I will talk to you later.